Hello, everyone. Hopefully, you're doing well. We're going to continue with chapter 2, functions and graphs. In this section, we're going to focus on combinations of functions, composition of functions. So what we're going to try to do is to find the domain of a function, combine functions using the algebra of functions, specifying domains from composite functions and determine domains for composite functions and write functions as composition. So that's mostly what we're planning on doing in this section. We would look at data, to see how we can analyze those data. So one of the things we planning on doing is to find a domain of a function. So if a function f does not model data or variables conditions, its domain is the largest set of real number for which the value of f of x is a real number. Okay, so we can see some functions like f of x equal to x plus 5. That's a function. So the 2 represents something. The coefficient of x, if you have a function like f of x equal to x plus 5, the constant term and the coefficient of the leading term also means something. So exclude from a function's domain real numbers that cause division by 0 and real numbers that result in a even root, such as square roots or a negative number. That means, remember, you cannot take the square roots, the fourth roots, the fifth roots of a negative number. That's very important when we're looking for the domain. That's we need to exclude those. If we have a functions with denominator, we know we need to exclude the number that would make the denominator equal to 0. So few examples where they would ask us to find the domain, find the domain of the functions. The first one, if you look at the first one, what would you say? Well, this domain, like you can see it, because it is only a linear functions. When the functions is linear, the function f of x equal x squared plus 3x minus 17 contains neither divisions nor a square root. For every real number x, the algebraic expressions x squared plus 3x minus 17 represent a real number. That's a domain of f is the set of all real numbers. So we can go and know that this domain for the first functions is all real numbers. You can write all real numbers, or usually we said negative infinity, infinity. It's only linear. There is no denominator. There is no square root. So we would say it's all real numbers. But if you look at B is a little bit different because there is not a little bit, it's giantly different because if you look at B, there is a denominator. Now you need to identify what number would make the denominator equal to 0. Because that function's 5x over x squared minus 49 contains divisions, because division by 0 is undefined, and we must exclude from the domain the value of x that cause the denominator x squared minus 49 be 0. So what we need to do, we need to set the denominator equal to 0, like we set x squared minus 49 equal to 0, then we solve. Now you're gonna have, if you add 49 to both sides, you're gonna have x squared equal 49. If you take the square roots, if you take the square roots of both sides, you're going to write x equal plus and minus 7. That means two numbers. When you raise it to power 2, that will give you 49, negative 7 and 7. So at this point, we can say for B, the domain can be everything except, right? We can say the domain can be anything except negative 7 and 7. So different ways of doing that. We can exclude negative 7 and 7. if we use interval notation, that means we can take everything from negativity infinity to -7. Right? I mean, parentheses means -7 is not included, but we cannot take any, we can take everything between -7 and 7. So, I mean, 7, negative and 7, 7 and 7 not included, but anything between them. And we also can take everything after 7. So that would be the domain in this particular case. Okay, so for B, first of all, because there is a denominator, we must verify that for this denominator, it's it's not equal to 0. If you look at C, C is stated that you have a square root. So the function h of x equals square root of 9x minus 27 contains an even root. So that means it's square root, it's 4 roots, it's 5 roots. Because it's an even root, we cannot accept negative numbers. Only positive numbers can be. So we need to make sure that whatever we have underneath of the radical, like 9x minus 27 must be greater or equal to 0, right? It cannot be less than 0. So if we add 27 to both sides, you're going to have 9x must be greater to 27. If you divide both sides by 9, x must be greater or equal to 3. Okay? So we cannot take anything less than 3. All right, so for this domain C, we would say that the domain for C would be, we must start at 3. So the smallest number we can go is 3, then to infinity, because we said it must be greater than 3. It must be greater or equal to 3. All right, because if you plug any number less than 2, because 9 times 3 is 27, 27 minus 27 give you 0, square root of 0 is 0. But if you take 9 times 2 is 18, 18 minus 27 is -9. You cannot take the square roots of -9, okay? Now, looking at J as in Jack, J of x, we said that for this one, the function's 5x over square root of 24 minus 3x contains both an even root and divisions. And you know in the denominator, you cannot have 0. So in this case, you're not gonna say that the denominator, we know we can take the square root of 0, but you cannot divide by 0. At this point, the denominator, like 24 minus 3x, must be strictly greater than 0. Must be strictly greater, not greater or equal to 0, because it cannot take 0. So we're gonna, if we add 3x to both sides, we're gonna have 24 greater than 3x. If we divide both sides by 3, we're gonna have 8 greater than x. So, or you can say x must be less than 8. Okay. Because if x is greater than 8, that's a big problem. 3 times 9, 27. 24 minus 27 would be -3. So we cannot take the square root of -3. All right. So we said it must be less, and it cannot be 8 also, because 3 times 8 is 24. 24 minus 24 would be 0. So at this point, we know that for this domain in D, the domain here would be, I mean, it should be less than 8. That means we're gonna go negative infinity and 8, not included. That's why we're using a parenthesis. Parenthesis means that number is not included. Bracket means, yes, the number is included, all right? All right, so if you don't have any problem with that, I believe we can move forward with a different example, especially talking about the sum, difference, product, and quotients of functions. So we can add functions. So if you consider having f and g to be two functions, the sum of f plus g is the difference, I mean f plus g, the difference f minus g, the product f times g, and the quotient f divided by g are functions whose domains are the set of all real numbers common to the domains of f and g. All right, so define as sum f plus g of x is f of x plus g of x. Right, you just need to add them or subtract those functions any times you want. Okay, so follow these instructions and you can add or divide, subtract any types of functions you have. That's extremely important. Okay, that's extremely important. So okay, sorry about that. Um, Combining functions. So if we have an examples, let's suppose they give you two functions, f of x equal x minus 5 and g of x equal x squared minus 1. The first thing to do here is to add them, because what we mean by that, we said it's f of x plus g of x. That means we have x minus 5 plus x squared minus 1. You combine like terms because it's only x squared plus x minus 6. And that would be the answer for that one, right? Now, when we do g of x, maybe g of x must be different. Why? Because there is a negative. When we have f of x minus g of x, I can just say f of x is x minus 5, but for g of x, I'm going to use a I can use parentheses for both of them because I need to distribute the negative side. So I have x minus 5. Now the negative distribute, make it negative x squared plus 1. You see, it's a plus 1. So we have negative x squared, no other terms to combine with it. We have plus x minus 4. Now, when it's a product is a little bit different again. That means you take f of x, you multiply it by g of x, then you distribute, you FOIL. So we have x minus 5 times x squared minus 1. If you FOIL x times x squared, x cubed, x times negative 1 negative x, negative 5 times x squared 5x squared, negative 5 times negative 1 positive 1. So if you see that, you cannot even simplify because x cubed minus 5x squared minus x plus 5, that's the best answer you can find. If you look at the last one where we said, oh, you need to divide the functions, okay? The divisions of these functions, as you can see, we simply need to follow it, all right? How to do it? Well, actually, we're gonna go with x minus 5 over x squared minus 1. We cannot do any more. That's the best we can do. They ask us to find the domain. Oh, they ask us to find the domain. Each of them, they request for the domain. Look at the first one, A. I'm gonna change the color for it. We're gonna go domain. What the domain for A? Yes, it's all real numbers because there is no denominator, no roots, no events. The domain for B, still all real numbers because there is no, we don't have any denominator or roots. C, again, the same, all real numbers. What's the domain for D as in dog? Oh, yes, because there is a denominator for this one, D, you must set the denominator equal to 0 and solve. If you add 1 to both sides, you have x squared equal 1. Remember, we're looking for only x, not x squared. Then we need to take the square root of both sides. Taking the square root of both sides, it gives us x equal plus and minus 1. So we have two values. At this point, the domain would be everything except -1 and 1. So we can write it in interval notation, negative infinity, -1, union, -1, 1, union, 1, infinity. So remember, parenthesis means the endpoint not included. They not included. So I'm hoping you're okay with that one, right? And that you can do it with no problem. Okay. Now, composition of functions. That's another one we can talk about. Composition of functions. The composition of functions, as we said, that's another way of combining two functions, right? You know, suppose, for example, your local computer store is having a cell, right? You can model that one very well by using composition of functions. So the composition of functions of f with g is denoted FOG. Okay, F0g, it's not a zero, it's FOG, it's denoted by the function FOG of x equal f of x, FOG of x equal f of g of x. That means if you have an f functions, everywhere you see x in f, you must replace it by g of x. It's like you said f of 2. Everywhere you see x in g, you replace it by 2. The domain of the composition function FOG is the same, is the set of all x such that x is in the domain of g and g of x is in the domain of f. All right. So that at some point how we're going to proceed to see this. Okay. Let's suppose we have an example. Oh, we have maybe more than one example. That's we're gonna do. First of all, for these examples, they're gonna ask you to, you know, given to these two functions, find FOG of x. That means everywhere in f. You know what? I'm going to make a big space. Maybe that's what happened. Okay. Let's try it. Okay. Everywhere in f I see x, I would replace it by g of x. That means because there is a 5, there is an x, I would replace g of x by that f, okay? I will replace f by x in f by g of x. So this is what we have, 2x squared minus x minus 1. So you see the only x I have here, I replace it by g of x. So I can distribute 10x squared, distribute the 5, minus 5x minus 5 plus 6. So 10x squared minus 5x plus 1. Okay, so that will be the answer. You know, you substitute everywhere I see x, I replace it by g of x. Now, some of them might look, might need more space, maybe this one. Let's suppose we're trying to do g of x. So that means everywhere in g we see x, we replace it by f of x. So that means we're gonna have 2 times 5x plus 6 power 2 minus 5x plus 6 minus 1. You see, everywhere I see x in g, I replace it by f of x. Now, let's distribute. we see that I'm gonna start here. First of all, the two women there, let's say first one power 2, because what we have here, a plus b power 2 is a square plus 2ab plus b square, right? So we're gonna have 25x squared, 2 times 5 times 6, 2 times 5, 10 times 6, 60x, plus 36. We can distribute that negative. Okay. Now let's distribute the 2. We have 50x squared plus 120x plus 72 minus 5x minus 7. Okay. Now you see what happened. We can even do better here if let me put another one. Okay. We can say that at this point, if you distribute, if you simplify, if it's possible, so 50x squared, 120 minus 5 is 115, x, 72, I don't know if we have to do that, we have 72, okay, minus 7 is 64, 65, sorry. Okay. Can I say okay? Okay, okay. Now, last questions they ask you to find is FOG of 1, negative 1. That means you could do it different ways. You either find FOG first, then you plug negative 1 in it. That's what we're gonna do here, because we already know what is FOG of x. Well, FOG of x is this one right there. We can substitute x for negative 1. So if we substitute x for negative 1, we're going to have 10 times negative 1 squared minus 5 times negative 1 plus 1. That gives us 10 plus 5 plus 1 is definitely 16. I know, I go very fast with you on this one, but it's because I know you got this. You got this, and that's supposed to be all fine for you. Other topics to see in these sections, which is very important, is the excluding values from the domain, for these type of functions, f or g of x equal f times, remember, is everywhere in f you see x, you replace it by g of x. The following values must be excluded from the input x. If x is not in the domain of g, it must not be in the domain of f or g of x. Remember, if it's not in g, then it cannot be in f or g of x. Any x for which g of x is not in the domain of m, f must not be included in the domain. So that's something we say that, and because we've been talking about it, and we say two different ways. Now look at these examples where they would ask you to form a composition of function and finding its domain. They give you these two functions. First of all, they ask you to find FOG of x. So FOG of x, that means everywhere I see x in f, I replace it by g of x. That means I have 4 over, what is g of x? Is 1 over x, so I replace it is 1 over x plus 2. All right, now we can leave it like this, or we can find some common denominator. We have common denominator, multiply the 2 by x divided by x, so we're gonna have 1 plus 2x over x. Remember, when you have a fraction divided by another fraction, keep the first fraction as is and multiply by the reciprocal of the second fraction. So you end up having 4x over 1 plus 2x. Doing some computation, that's what it's gonna be, because remember, when you have the same denominator, all right, first of all, I look for the same denominator. Then I have a fraction divided by a fraction. I keep the first one as is, 4 over 1, and I flip the second fraction and change the division sign by a multiplication sign. So for us, this is the FOG of x equal 4x over 1 plus 2x. Okay, so let's say this is the functions, right? Now, the goal, first of all, for g of x, we know x cannot be 0, right? This is g of x. For g of x, when we're looking for the domain, what we said, if it's not defined for g of x, it cannot be defined also for f of g of x. Remember, for g of x, x cannot be 0 because 1 over 0 would be undefined. So for g of x, x cannot be 0, okay? So we know for g of x, x cannot be 0, okay? And then we're gonna do the same. That means for us, the domain here would be negative infinity 0, union 0, infinity. So that's for g of x. Okay, that's the domain. Now, for f of g of x, what's happened? Can you check for f of g of x? What is the domain? Look, for f of g of x, all you need to do, set the denominator equal to 0, 1 plus 2x equal to 0, subtract 1 both sides, 2x equal 1, so negative 1. So x cannot be negative 1/2. So remember, for f of g of x, x cannot be negative 1/2. So if you remove that with negative infinity negative 1/2, union negative 1/2, infinity. But we're not done. What we need to do, now we have an idea of where to go with all of this. We can do now, so the domain for FOG of x is negative infinity negative 1/2, union negative 1/2, not to infinity, but we're gonna say 0, because 0 cannot be on it too, union 0, infinity. So this is, I take each of them separately, then I combine them to make them be only one function. So I'm hoping you got that one. I would let you to enjoy another examples on your own, and you would let me know if you have any questions on this. Have fun. I'll see you in the next video to cover especially section 2.7 inverse functions. Take care.